Hey everybody, nice to have you here. I'm Alexander Paschall. So I've been working at Epic Games since like 2014. So I've been working there for quite a while now, and I was actually one of the original beta testers back in the day for what was, we had a code name for it, but it was UE4, the old beta for it. I worked also as the community manager for Unreal Engine as well as tech support, and so I'm both technical sided, like knowledge sided, and also I can help you with marketing and I can help you get connected in networking. So I'm kind of a little bit of a everywhere generalist with Unreal. I like to kind of say that because Unreal made me into a proper game developer from being a guy who modeled rocks. My job entirely when I first got to Epic was model a bunch of rocks, model a bunch of high poly stuff, try to break the engine by making super, super high poly things, which is just like crank up the turbo smooth, like really high. So it was nothing. Then one day they introduced me to blueprints and it changed my life forever. I mean, completely changed my life. Like until I met my wife, it was like the only life-changing event I really had. So really, it got me from I model rocks. I do AI now. I'm building A-star pathfinding systems entirely in blueprints. I'm building all of my stuff in blueprints, huge like complex villages of people, this, that, and the other. But I'll tell you what, we all get started in the exact same place, and that is a couple of simple tutorials on things like how do I control logic flow and stuff like that. So we're going to do a classic, a door tutorial together. This is going to be, if you've used Unreal before and you're already very familiar with it, you're going to feel like this is pretty obvious stuff. But if you've not really gotten a chance to use Unreal a lot, you're going to find that this might help to contextualize, to help you better understand why we do things in certain places. I'll also try to kind of make sure that you understand the architecture behind how we expect information to flow from the player controller, where the player presses buttons and it goes through a controller, and then that gets pushed down to the possessed character. And then we can also, from that possessed character, the character we're playing as, interact with objects around us. So we're going to be building a door tutorial, we're building a door with this tutorial, which is pretty straightforward in a lot of ways. And then you think, well, actually there's 100 different ways to make a door. So we're gonna make a simple door with a lock, and we're going to have to go up to the lock, hit it, and then when we hit this lock, it's going to open a door. That's a completely different object. So we're going to communicate from one object to another, and we're going to communicate from the input device just by pressing keys, input, to our character, to objects into the world. So let's get started. If you've got your launcher open, you can hit launch on the latest version of Unreal that you have. And no, you don't have to worry. If you have 422, 421, if you had 4.7, this would still work. This is the very basics of blueprints. It's been in there since 4.0. So you hit launch right here and you're in here, or if you have it already, you can just jump right into it through your little hot link there. Let me bring this open. So this is our project browser. This is where you're going to be picking how we're going to interact by kind of default. We've provided you a lot of templates, and I really think if you're going to get started in Unreal, go on to our docs.unrealengine.com. Then you can go and check out all the template breakdowns where they explain to you all these templates and why they're built, how they interact, and we even give you suggestions for how to build a game out of each one with a bunch of like lists of cool links for new stuff you can learn about. Today, we're not going to actually start with a blank project. We're not that good yet. We're gonna assume this is really our first time, and we're going to let Epic hold our hand a little bit. So we have concepts like first-person game, where the camera is going to be controlled from a pivot point inside of the character. We also have things like third person, where it went is, there it is, third person. There's our third person one. Instead we're going to pivot around the character from the outside with an external camera, stuff like this. And then you also get to see your body as you move around. That's really good if you want to get started with learning how to do character animations, by the way. So if you're like really new to character animations and how they should work with blueprints, take apart the third person character and you'll find a lot of good stuff in there. We're going to just do it with a first person character today though. I just wanted to let you know, these are our two most popular, first and third, but there's so many others, vehicles, all kinds of stuff. We're also going to be starting this by looking at these three icons. These are our settings for our defaults. You can change this information later, but this is just going to help establish exactly how we want to build the game initially. So we have desktop and console as one option. We also have mobile and tablet. which is going to kind of scale down some things, but it's more that it's going to give us a different way of UI interaction, where it's going to kind of assume we're trying to use touch screen more than anything else. But we're going to keep this on desktop and console, just to keep it simple for right now. So we've got maximum quality on, which is fine. We also have an option for scalable 2D and 3D. This is really easy to change later. So if you make something high quality or 2D, 3D, and you realize you needed to change it, there's settings for that too inside the editor. It's just easier to start kind of in pre-production knowing where you want this to go. So maximum quality is fine for here. There is one thing we're going to change where it says no starter content. If you were starting a whole new game and you wanted to make sure that you didn't pick up any extra stuff from Epic, you'd leave that off. But in this case, we want some default game objects, and Epic is going to provide that for us through our starter content. This gives us particle effects. It gives us some extra meshes that we can mess around with, and it also gives you a couple of audio tracks so you can see how we make these. They're pretty cool. And all we have to do is find somewhere to store our project and name it. I'm going to call this one IGDC 2019 demo. So that way we know exactly where it's from. Just hit create project and we're off. I need to play Alan Wake. I keep downloading all the Epic Game Store free games and then I never have free time to play them. It might hang around 91% as it builds lighting. I've been doing this so long, I know what the percentages mean. So if you're it hangs at certain percentages, I can probably tell you why. So 90, yeah, it's building lighting. There you go. Boom. All right. So this should be familiar to you if you've opened Unreal before, except I tend to put my content browser to the side. It might be down kind of below by default. I just find it easier to move that over. You can click these and drag them around to rearrange, like so. You can also right click them and hide the little tab bits. So down here is my content browser. And this is where I'm going to be storing all of my project assets. This is sort of like your project folder or whatever. It's going to have all of your U assets. And so this is where we're going to get started. I'm going with the assumption that you have a general idea of this is a user interface. You can right click to rotate, right click WASD will let you move around, QE up, down, get you flying around a little bit. So let's actually build ourselves some blueprints and dive into blueprints a little bit. If we click the Add New button, we're going to have an option for Add New Blueprint Class, or in this case, I can go into the Blueprint folder, right-click inside of here, and I can create a new Blueprint class like that. It'll go into this folder. You're going to get this Pick Parent class, and I'm going to run down the list really quickly because these are all of our most important classes brought forward. There's also a drop-down for all classes, which will unlock hundreds and hundreds of pre-made concepts. So if you're wondering how to build vehicles and wheels, do not reinvent the wheel. We already built wheels. We understand how wheels, tire friction, and all of that work. There's a class for that. So go ahead and check out all the different stuff you've got kind of pre-made. And I'm going to bring that back up. So our common classes. First up is actor. The way that I like to describe actor is the idea that you exist. It's an idea of any object in the world which must exist in the world somewhere tangibly. It holds ideas of I am here in XYZ coordinate, and it holds ideas of I can have tick and it will constantly update on frame. It has all of these nice pre-made ideas that you need for any given physical object in the world. So when you think chair that you can sit down on and interact with, think actor. In this case, doors, locks, all that. We'll be using that class, but I'm going to explain to you these other ones down here. So we have pawn and character. Pawn is derived from actor. It already knows where it has a position in space, etc. And Chris kind of went over this if you were here for the morning session. For those of you that weren't here for the morning session, also you can hover over these, hit Control and Alt, and if I get lucky, there we go. You can click See Full Documentation, and anytime you're confused, you can usually hold Control Alt, and there's like a little Find Full Documentation, and that'll help you a lot. The pawn class is the idea of we have an avatar in the world, a physical being which represents us, the player, that we push around using our controls. The controls come in through the player controller. The character is a derivative of the pawn, which it comes with some extra stuff since the pawn has some movement concepts, but it doesn't have much past that. Character's just our way of providing you a really generic concept of a bipedal person who stands upright, and it comes in with a little capsule collision. The capsule collision works with a lot of different other types of systems, like our movement system and our animation system are all kind of looking at that capsule. So when we're talking about collision with a character, don't think about the mesh, which represents the character. Think about the capsule shape. The player controller is how we digitally represent a physical human. So even though we have this person that's a character floating around in our world, running around, that's not actually the player. The player is closer to the player controller. The player controller, when I press a button on whatever, like my keyboard, my gamepad, first it comes to the player controller, then it shoots down into whatever we're possessing and controlling. It's like our spirit, it's like our thoughts. It is the digital representation of a physical player. So you have to kind of keep that in mind. Game mode, in this case, game mode base. Game mode is what sets our defaults. It says when I load up my game and I say play, it's going to say this is the default character, this is the default controller, and you just choose the classes and inject them into this. And then you assign the game mode either to the level or to your whole project, however you want to do it. These other two are just making components. That's advanced stuff. Not yet. We don't have to worry about that today. In this case, once you have this open, click on actor. So we're going to open up a new actor. There we go. And I'm going to call this one lock, enter. And I'm going to do that again. So I'm going to right click, blueprint class, actor. And this one will be door, D-O-O-R, door. Boop. So we've got our lock and our door. We double click open our lock. You're going to see a lot of nothing. So currently our lock looks like nothing. In order to actually create our physical components of this, we go up to our add components list up here. Everything that shows up in this list up here is going to be what's actually part of this actor derived thing. So in this case, part of our lock, we can actually see up here in the upper right what its parent class is. It will inherit everything from actor class. And if we made a big lock system here, and then we decided we want to make a different type of lock, we could derive from the same lock and reuse all of the code from this, and then give it a different mesh or color it pink because that's cool, why not? But the parent class matters a lot because it's object-oriented programming, so that's going to kind of keep going down the chain. Now, click on this add components list here. We need a mesh that's actually going to be the mesh that the player sees. So we just type in static mesh. There's several static mesh options here. We're going to choose the one that's just static mesh. The other ones are for making instances and reusing the same mesh, but reducing draw calls, basically. It's ways of optimizing meshes that are more for looks, for visuals, but we're going to use a mesh we're going to interact with and do stuff. So grab that static mesh component at the very bottom of the list. There you go. And I'm going to call this one lock mesh. We're in the lock. We are putting in the lock mesh. You'll see it became uncompiled. It says dirty, needs to be recompiled. We're going to wait. It doesn't matter. We have to add in more stuff still. So click on add component again. And this time, sorry. We have to assign it a static mesh. Woo. So if you go into the right side here, you're going to see your details panel of all the information about this mesh. And in this case, there is none. It's a static mesh property none here. If we hit the drop down, we can grab any given mesh that we think is appropriate for a lock. There is a mesh called corner something. It's like, yeah, there you go. SM corner frame. And it's like a little technology box. It just looks like a little box with like some general tech feel to it. There it is. So I chose SM corner frame, and that gave me this little box. All right, so that's what the player will see. The other thing that we're going to add in is we're going to hit add component, and we're going to type in box, and there is a box collision. This is going to create a volume, like a big cube volume in space. We also have things like sphere collision. We have a capsule shape. We have a few different shapes. In this case, I think box is the most appropriate. So I'm just going to call this one, yeah, sure, box. Doesn't matter. Remember, the player's not going to see this, so we can call it whatever we want. And I'm going to scale it up. It's a little small. I'm also going to grab it and move it forward So relatively, when I drop this asset in the level, this box will be kind of in front of it. And we can change its box extent, or we can scale it. Either way is totally valid. Either way is going to make the box larger and will totally work about the same way. So I'm going to just change the box extent to 64, 64, and 64. So it's a much larger area. I'm just keep that kind of together, but I want it forward. So we have to walk up to it by the front. We'll kind of fly up to it and be like, yes, this is us touching it. Now, if I actually scroll down on this component, any of your components at the very bottom are going to have a list of all the potential events they can trigger. Events are just function calls that are triggered by something Unreal has kind of set up for you. So in this case, we have stuff like on hit or on overlap. We're going to use on overlap, but there's a few different options in here. Now, these tabs where it says viewport up top, construction script, and event graph are how we flip through our different ways of adding either logic or components. I'm going to click on event graph, and we're going to see we have a couple basic ideas like begin play. When the level first loads, this will trigger. We have actor begin overlap. So if any component in the entire actor gets overlapped, then this will trigger. Then event tick is every single frame. So this is basically constantly. Keep doing this constantly. Avoid tick. It's, pretty heavy to constantly try to fire off functions. So we're going to actually select all of these and hit delete because I don't need any of them. We're going to use a different overlap instead. By selecting our box, you can see you still have the components list even if you can't see them. And then the details over here, we can hit on component begin overlap plus, and there it is. And then box again on component end overlap plus. Now you can only have one call of these in blueprints, so you have to figure out how you're going to use it exactly, because if you try to call it again, it's just going to snap you to it, show you where you're using it, and then you can find some way of manipulating it better. So we're going to test out and make sure that our collision is working on our box. We're going to drag off of this top pin. If I hold control, I can zoom in more. This is our execution pin, as this top white one. You should think of this as your line of code. As this goes down, or as this goes across, it's like going down your line of code. So you can start reading it from left to right like a sentence instead of top down. Then we have a series of output pins, and these are all the outputs of data about what overlapped us. And we can even break it down further. This is a struct of even more information, so we could have even more info. In this case, though, we just want to know, did something run over us? So we're going to drag off of this top execution, and drop it off here. When we let go, we're going to get a list of every possible function call or anything like that that we can call based on what blueprint we're in. It is context sensitive. See that checkbox? So sometimes you might need something that you're not sure where it comes from. You can uncheck it and basically get everything, all possible actions. But in this case, we want context sensitive on, and we want to print string. There it is, print string, and hit enter. And there it is. There's our first node. So the whole object here is called a node, and this is called a pin. So these little input and outputs are pins. Instead of snapping in a string from some variable or from some other place, we're just going to type it in manually. Where it says hello, we're going to say player is overlapping. Boop. That's it. That way we'll know that the collision worked. And then we can actually copy it, Control C, Control V. Hey, copy paste. By the way, you can email someone a blueprint by copy pasting your blueprint into text, and it will totally work. It's actually one of my favorite little tricks. I'll show you later. It's cool. In this case, the last thing here where it says player is overlapping, we want to change that to player is not overlapping. All right, hit compile. Now we're ready to actually test it. Really quick, compile. I can drag this over. So now I have two tabs. I can tab between them. It's way faster than trying to do different windows. And we're going to drag the lock out of our content browser. Click it, left click it, and drag it into your scene. There it is. And it should just appear. And I'm going to put it on this little wall over here. And I'm going to rotate it so it's coming out like so. I'm also bringing it down a little bit. If I hit F, the F key will zoom to anything you have selected. So I can get a better look at it by hitting F. We're also going to make this a little easier on ourselves. If we go into the lock, By default, this box is not going to render in the game. It renders here as a debug object kind of thing, but if I click on the box collision here, back in our lock, the box, I can just check off hidden in game. So it's visible, it says rendering, visible, and hidden in game. If I uncheck hidden, when I hit play, I hit compile again. So uncheck the hidden property of the box, then hit compile again. And now when I jump out, yeah, that was a little fire off there. And look, there's my box. You can actually see it instead of it being invisible. When I overlap it, I overlap it, it's going to say one thing, and when I hop back out, it'll say another. Players overlapping, players not overlapping. And you can see it's actually firing off a handful of times, and that's because it's picking up all these components. It's just everything that goes into it, it fires off. So in this case, we're actually going to just check for if it's the character instead, if it's our character instead. So instead of players overlapping being print string here, we're going to hop back in here. I'm going to hold Alt and left click to disconnect these. I can just drag these over a little bit more. And if I do this, I click on other actor here and drag off of this. There's a couple ways we can determine what it is we've hit instead of trying to just kind of take a wild guess. So let's just cast to our character here, first person character. There it is, cast to first person character. This is also going to allow us to get information. So if we run over this and we want to know anything about the guy we ran into here, we can drag off of here and get information about them or run functions out of them. But basically we just loaded them and now we're connected. This is one way. Casting is one of a few ways of communicating out and in to different blueprints. Now, if this is correct, then we're going to run that print string again. And again, we can copy, Control C, Control V. We're going to connect the other actor to the object. And then we just need to make sure these white execution lines are hooked up one after the other. Bump, bump, bump. All right, let's see if that helps out. See, now my projectile, if I shoot into it, won't do anything anymore. Oh, nope, it's still picking up every time my component goes in. But at least we know it's definitely the first person character. My bullet can no longer actually trigger it. If a random person wandered into it, they wouldn't trigger it. But all we need to know is either we're overlapping it or we're not overlapping it. And that's all we got to do. All right, so we're going to set up our first branch. And we're not going to use these anymore. These are debug objects that kind of suck. So I'm going to hit delete on both of those. And we're going to add a new component on top of all of this, where it says add component here. Click on add component and find text. There's a text render component. Text render component is good for creating a very fast, dirty kind of text that floats in space. We also have UMG. If you want a better system for putting up text that looks good and can be manipulated and do cool stuff with it, use our UMG system for our UI stuff. So instead, text render, and I'm going to call this one, let's see here, interaction text, yeah, interact text. And this is going to show up in our viewport right on that button, see that? So I'm going to move it just over the button. And we're going to make it say, press E to use. So that way we know the player gets up close to it, and we'll make this pop in, and when we leave it, we'll make it go invisible. And then that way we'll know if the player's close or not also. That's kind of the trick. And in the details, we can change it from being left-oriented here to center. And there it goes. It's nice and centered up now. I'm going to say, in the text field, press E to use. And now it changes the text. Finally, I'm going to uncheck visible. So it will not be visible by default. We have to overlap it to make it visible. So uncheck visible, and the text will just vanish. In our event graph, we're going to take that interact text, drag it out here, and you're going to see we're going to get a reference to it. And if I drag out interact text and let go, now we have this little reference, and I can drag off of this and type in set visibility. We'll get this new function, and because it's context sensitive, it automatically connected it to the target. We're setting the visibility of whatever is the target object. And then the new visibility, this checkbox, if it's checked on, it equals true. If it's checked off, then it's false. So we're going to connect the top white line. So if casting succeeded, then that means that the player is entered. And we're going to check on new visibility right there. And we could actually drag off the same exact node and type in set visibility again, or we can copy paste, of course. Set visibility. And same thing, top execution pin, connect. And this time it's unchecked. So when we overlap it, turn on visibility. When we stop overlapping it, turn it off. Hit compile again, and we should be able to hop in and press E to use, press E to use. Hey, that looks proper. Cool. So now that we have that figured out, we can actually start kind of trying to figure out how we're going to communicate and that we're trying to press a button and do stuff when we're overlapping. So first, we should probably store a Boolean variable that says that we are currently overlapping or not, so that we can use that in our logic. That's pretty easy. We can hit plus variable right here. So it says variables, under my blueprint, variables. You can hit plus, and the default you see is red, and in the upper right, red is Boolean. And I'm going to call this one, there we go, I'm going to call this one is near lock, question mark. Booleans are usually questions, so I like to put a question mark there. Putting a letter B before it would actually technically make it the best. If I said B is near lock, that's technically the most correct. Now your variable type drop down here, you'll see is color coded. Boolean is what we're choosing, so don't change this. I'm just showing you. We're color coding things a bit. All the green stuff is a number. So all these different shades of green are different types of numeric values versus different shades of kind of purple, pink. Purple and pink colors represent character. They're all characters. They hold some form of non-numeric characters, but they can hold numbers, but they don't count as numbers. So it's all text. And then we have yellow for vectors. We have, rotators, which is your rotation. It's just a vector with clamps, basically, and some gimbal lock stuff and some other stuff that's for rotation. And then transform is a combination of a vector for location, a rotator, and a vector for scale. So transform is all of the properties you need to place something in the world and have all the data you need about that. So just a Boolean for right now. And of course, yeah, there's tons of others, but we're just going to use the basics. So Boolean. So just like we're setting the visibility, we're going to drag our Boolean here out into this. When I let go of it, we can set it. So setting it lets us change it. So if I click and I drag and I connect the execution into this set and I check it on, now it is equal to true. When I overlap, this will now become true. I can copy and paste it, Control C, Control V, uncheck it, and connect it up to my end overlap event. So now those will flip back and forth. All right. We're going to create something that's going to actually allow us to send information in as well. And this is going to kind of block whether or not us pressing a button can actually be seen or not. We're going to create a new input. I'm going to go back over to my first person example map over here. And in the settings menu, project settings, we're going to create a new input. So settings, project settings, and then halfway down the left side here, that's your input. Click on that. And if you saw Chris's stuff yesterday or you watched his talk this morning, you probably already have an idea of how these work. You can easily bind multiple inputs to a single function call in Unreal, and then those function calls can be brought up by anything. Remember, these are going to go through the player controller first and then show up in whatever else it has, but we'll just make this go directly into the lock, which is a little bit of a weird practice. Technically, we should make the inputs go to the character and then find a way of seeing the lock through the character, but we'll make it easy on ourselves. So we have action mappings and axis mappings. The axis mappings allow us to kind of get a constant value from whatever numbers we give it. So we can kind of figure out if W is equal to 1 and S is equal to -1, then it will constantly check to see if you're pressing W or S. And if you press W, it'll start outputting 1. And if you press S, it'll start outputting -1. which is helpful if you're trying to like push forward constantly or pull backwards constantly based on if something's held down. Also, axis mappings can be good for if you have like a trigger and you're pulling the trigger halfway down on a game controller. It'll detect like 50% to 100% and it'll figure out how far down you've pulled it. Our action mappings are instead a button press, one and done. I like to think of it as the punch button. It's you press one button and it happens. You press space bar, you jump. It's not constantly checking. It just waits for you to hit the button. In this case, we're gonna hit plus right here. And I'm gonna make this be called interact function, which is maybe not the best name, but you get the idea. Interact function. And so we hit that plus next to action mappings. That gave us a new one. And if I hit the drop down, we can see it's currently mapped to nothing. I can click this drop down and I can map this to E. It's actually probably easier to go over to keyboard, drop it down from here, and just scroll a little. There's E. A little bit easier to find it, because if you type in E, it's going to find everything with E in it, which is a lot of different words. We can also hit plus again and use this drop down. And I'm going to map this one to gamepad. This one's more specific. Face. And you see these are face buttons. This refers to the X, Y, A, B, these buttons on the side of the controller. And this will instantly map it to every controller. If a controller has 4 buttons on the side, guess what? This one is going to do it. So if I do this on button left, that would be like X on an Xbox controller, a square on a PlayStation 4 controller, or Y on a Switch. It's now mapped to all those. We can now make this for all those consoles at once. Done. We're actually totally done. That's it. These extra checkboxes are if you want to make it so you use like Shift W is sprint. I don't recommend using these if you're going to be going to console and back and forth between console PC, because you might accidentally create a scenario where the player has to use a game controller and then also have a keyboard hooked up too, so they can hit Shift and forward. You don't want to do that. Instead, it's just better to make these one-offs, and then you can map Shift itself and like everything to like a sprint button. It's better to do that. So I'm going to hop back over, and we don't have to save. There's no compile, no save. Just the second we make it, and I go back to lock, once I right click, I can type in event, and I'll be able to find that event. Interact, there it is, interact function. So anything can now find this interact function event. The thing is, though, since this isn't a pawn and it's not getting possessed, it's not something like that, we're going to have to find a way to let it know to look at the inputs. So you can actually override over here. Where did it go? There we go. If you go to your class defaults, you can change this so that it also picks up the game controller. That's why it's a little odd. Normally, you just want to push things into your character and then move from there. But for the sake of brevity, and not having to set up vector math of doing line trace forward and all that, I'm just going to go over to class defaults, input, auto receive input, and I'm just going to get this from player 0. So that's going to force it to take whatever's coming in through the first player, as in me, and it's going to push out here instead. So this thing is going to get to override our controls, which is great. That's exactly what we want. Now, we're going to create some way of gating off once we're close to it, and luckily we made that Boolean. So I'm going to take B is near lock, drag it off, and this time I'm going to get it. So now I'm going to check to see if is it currently set to true or is it currently set to false. If I drag off of this and I type in branch, I'm doing it wrong. But it's actually how you can get a branch. There's much better methods to getting a branch. A branch is an if statement, by the way. So if you drag off of this Boolean and type in if, enter, oh, it's a branch also. So if you're already familiar with the syntax of C++ and you start typing in a function you commonly know in C++, it's probably going to give you the equivalent here in blueprints. So in this case, we got our branch. Oh, you can also hold the letter B and click. There's hotkeys, B, S. There's a few of these. I'm going to figure out which ones are which today. There we go. Yep, do in. So there's a few you can work with. You just need the branch. So this branch, we're going to hook it up to press. And when it's true that we're near the lock and we press the button, it's going to fire and it's going to pop out this side. So we're going to drag off of here and I'm going to type in print string And we're going to change this string to say, let's say, using lock. So now we're not going to print string until I can actually get into the box and hit E. I'm going to hit save, compile, compile, save. All right, let's try. Hit play. E's doing nothing. I walk in here, press E to use. Using lock. Now, here's my favorite feature in all of Unreal. This was the moment that I went from artist to person who understands things besides art. I'm going to grab that lock up here. While I'm still playing, and I hit Alt-Tab, and I've jumped out. I'm going to drag the lock over, and I'm going to do this little split screeny thing that you can do on Windows, just so you can see both. When you're working with two monitors, it is so good. It is so good when you're working with two monitors. So I'm going to zoom out, and you can see my whole blueprint while simulating. Make sure I choose the right lock. Yeah, there he is. Chose my lock. Now when I hop back in, oh, I left. You see the little red thing fire off? I walk in, it fires. It fires, it fires, it fires. And look at the top part as I hit E. Boop. Oop, I have to get closer. Boop. There it goes. So I'm going to zoom in on that, and you can see I'm going to walk out. You can actually see it setting it down there way at the bottom. And if I hit E, it goes nowhere. See the little red just stops. I walk in, hit E, and now we can go through the true path. So that's how it works. And it flows like a river. Just think of it as you're directing the control of water. You're flowing it one way or the other. It can't really split, and instead it has to do things one after the other rapidly. There's methods of doing that. So in this case, true. Now, we should create a few conditions around actually getting this thing open, and we don't have to make it like work the first time. Let's make them like work for it. The lock is a little jammed. They have to like a couple more times. We'll create a counter for that. So I'm going to get rid of my print string really fast. And I'm going to make this go back to regular size. There we go. So let's make them count a couple of times, and then we'll do another branch to see if we've hit a threshold. And after we hit the threshold, we can actually do something different. So go back over here to your variables. It says plus variable. And then we're going to call this one unlock attempts. Attempts. There we go. Oh, not you lock attempts, unlock attempts. There it goes. Unlock attempts. On the right, you'll see we're a Boolean. Unreal will keep using the same variable you previously set up. So first it does Boolean by default, and then if you change it to float, then the next thing will be a float or whatever you've set previously. It kind of assumes you want to create a series of the same thing in a row. So variable type, hit the drop down, and we're going to go with a integer because we want this to just be a whole number. We could also use a byte because it's a small number typically, but integer for argument's sake. And every time we get near it and we hit it, so this is us attempting to hit it, we're going to add 1 to our unlock attempts. So get your unlock attempts. If you just set it, like if I come in here and I say set like this, then I'm just hard setting it. It would just be like 15, and I set it, now it's 15 forever. Instead, we want to add to it. So there's two ways you can do that. You can hit plus, and we could do integer plus integer and tell it +1 every time we go through here. And then we would have to tell it to set itself again. So we'd say, take your current value, increase it by 1, and then set yourself again. But there's a better way of doing this, and that is through an increment. If you're already familiar with programming, you're like, well, where's the plus plus, Alex? It's right there, plus plus. There it is. That's plus plus. So this and this are equivalent. It's the same thing. It's saying, take this number, add 1 to it, and then set it again. This is great if you're getting through a series of things. So I'm going to use this. That's plus plus for you. But there's tons of math nodes. You can do really cool math stuff. I just want to show you that there's more than one way to do anything. So yeah, if you wanted it to be increments by 2 instead, it's up to you. So I'm going to just delete these extras. And as long as this goes through here, true, it's going to keep counting up. All right, let's do another print string and make sure that it's working. Print string. Oh wait, to string. If we drag off this is actually another getter. If I type in to string, we get to string integer. And that's going to give us the integer, but as a character value instead of a number. We can drag off of this and type in print string. And there it is. So it's already snapped together contextually. We can also just right click anywhere and type in print string. It'll just not be pre-connected. Oh, that's print text. Ha, my bad. But it's just not going to be pre-connected. So connect the white wire. That way it knows to fire the print string as well. And now when we go in, we should start getting a number every time I hit E. So there I am. We're running. I go in, press E to use, enter, 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 enter. And it's working. It is incrementing that number. And then it's reading it and printing it. Cool. Actually, you could kind of see it in the background, kind of trying to do that too. Let me try to drag it over a little bit. All right, I'm going to cheat by being kind of low to the ground there. And there you go. Every time I'm hitting it, it's just firing through that same branch again and again. All right, so let's create some conditional checks. Once this number is greater than a threshold, then we should progress past that. So I'm going to get rid of my print string and my convert node. We're going to keep pressing forward. So after this increments, this will be the updated number. And that updated number, if I drag off of here, I can type in greater than, and I'll get greater than equal to. We can also do like a couple other numeric functions and stuff, but I'm going to just do greater than integer. And if this number is greater than whatever b value we put in, this will turn true. So you can see it's outputting a Boolean. So every time we run through this and we try a function call, it's going to read whatever this is. So let's make it 5. That you know, not like a million. That's annoying. So let's just make it 5. Just a few clicks, and then we can drag from this and we can branch. And again, make sure your white execution line is hooked up. So in total, now we have the input action function, which is if I hit E, or if I had a gamepad. Actually, right now, if I had a gamepad, I could just plug in an Xbox controller. This would all just work too. And then we increment, and then we check our increment. And if it's true, I'm going to print a string here. I'm going to manually type it in and say, let's see, threshold met. Threshold met. There you go. And I'm going to make another one, and it's just going to say keep trying. Keep trying. It's encouraging. I don't like to be pessimistic. So it's going to, yeah. Keep trying to knock the door down. All right, compile it again. And if we hit play, after we now have this branch, nothing's happening. Okay, go in, hit E, keep trying. Threshold met. And after that, it just keeps saying threshold met. There we go. So we got over that 5, and then now it's switched to true. So yep, it's just another Boolean value right there. Now's kind of the interesting part. So clearly it's time to open the door. We've been sitting here banging on this lock for a while. Now I should tell the door it needs to open. We're going to have to actually create some way of referencing a target. With object-oriented programming, it means that we're going to have to find a way of getting a reference to the other thing we want to talk to. Then we can either tell it to run a function, or we can pull information out of it, try to run a function ourselves and push it back in. That's kind of crazy. So what we'll do is we'll create a way of passing information from ourselves to this target door that we're going to put in our level. But first, we're going to hit variable plus, and we're going to create a new target of the type door. So hit variable plus, and I'm going to call this one target door. And we're going to change this from an integer to a door actor. So if I hit the drop down and I type in door, it can find any of the other like classes, any class you've created. In this case, we have a blueprint class of door. We're going to get an object reference to it here. So what that means is we're looking for a specific door. And if we want to be able to manually choose the door instead of having some like, line trace forward from our character, whatever we hit, that's the door we're trying to hit. No, that's all vector math. We're trying to be easy today. So we're just going to check on instance editable here. It's going to cause the little eye icon. See, it's looking like a little yellow icon down here to open up. You can also hit that to check it on. But what that means is when I drop this lock in the level, it's going to have if I select this lock now in the level, and I go to its details, it's going to have target door right there. And if I have a door in the level, I'll be able to target it, but I don't, so it's empty. So there's no door. That's the problem now. We need to tell our door something. It needs to know how to open and close. So we need to tell our door, first we're going to put some components in it. We're going to create the idea of it rotates to open and close, and then we're actually going to communicate and jump across using this target door. So I'm going to now leave this open, save, compile. I'm going to leave open my lock, and I'm going to double click on door, and now I have a tab for door. Now I'm going to show you guys a little trick. This happens to a lot of people, and I don't want you to panic if this happens to you. So if I hit escape immediately, and I didn't put anything at all in there, and I double click door again, oh my God, it's gone. No. It just thinks that you're just trying to input data alone into this particular thing. So click on open full blueprint editor, this little hot link up here. See, it says this is a data only blueprint, so only the default values are shown. I get panicked calls from people because they don't read this first line, and then you click that and life is good. There's your whole blueprint again. So let's get into this door, and we're going to put in two static meshes this time. We're going to hit add component and type in static mesh, just like we did before for making our little lock. Static mesh. And this one's going to actually be the frame, so door frame mesh. This will be the frame goes around the door. And if we use this drop down to choose our static mesh, here it goes. And I type in frame. Oh, there's a couple, but there's door frame, SM_door frame. This is in the starter content, so this won't exist unless you add it in starter content. When I click it, hey, there's my door frame, looking good. This white bubble, by the way, is our root actor. It just represents the center of our blueprint. So you can just leave it be. You can also like hide it from yourself, but trust me, it just helps give you the idea of where the origin point is in the middle of this blueprint. All right, we're gonna add in another component, and this is gonna just be our static mesh again, static mesh. And you can see it got parented underneath the frame because I had it selected, but this will be our door mesh. Door mesh, there we go. And over here under static mesh, if I just type in door, there is door, there he is. Boom, oh, and it's a bit off center. So we're gonna drag it over, and it's gonna do this thing where it doesn't quite line up, so we have to get a little bit smart with it. So it's like, oh, there's a little gap here. But that's because it's actually built with, it's like, I'm trying to remember, it's like 105 or something across. So it's got like a 5 in there. So up here is where we have our snapping to the grid values. I'm just gonna change that to 5. So I can snap to that 5 and boop, perfect. Now it'll fit in perfectly. You can try to free form it, like you can do, you can uncheck this entirely and like freehand it, but I don't recommend it because you'll end up with weird values, or you might end up putting something slightly off where you want it to be. You can also see down here where the pivot point is, this little point, that's actually where we're going to rotate from. If you're exporting from 3ds Max or Maya, wherever the origin of the level, that cross in the level is, that's where the pivot's going to show up. So if you build your door and the pivot's in the middle of it, your door's going to rotate like, woo, like from the center, and it's going to look weird. So push your door off to the side, make sure the pivot is on the corner, and then it'll rotate from that pivot point instead. It's way better. So just remember the origin in your 3D modeling. When you export it from there, that's what's showing up. So I've had a lot of people where they'll model out a whole city, and they're like, yeah, this house, they build a house like 3 miles down a road, and like, yeah, cool, I'm gonna export that into Unreal. Then they go into Unreal, and it's like, the house, it's like I opened it, but the house is like way down there. What the heck happened? Like, well, you modeled it way down there, bring it to the origin, and it will be in the correct position. So just keep that in mind when you're modeling and you're exporting and importing. The origin point is key. In this case, it's already set up the right way. We're also sort of cheating. So there's a small cheat here. The door doesn't actually have collision. So even if we screw up, we can walk right through the door. If the door swings into our face, it's not gonna hit us. I can actually open up the static mesh by double clicking it. This is the static mesh editor. And if I type in, if I hit collision, simple, there's nothing. There should be a green box around it to signify collision. So we're gonna leave it without collision just so it doesn't smack us in the face if we're too close to the door. But typically, yeah, you want to have that give collision in your final project. All right. Now, before we can actually trigger anything, I'm going to delete these again, by the way. Let's just delete them. They're just extras. Boop. Unreal's trying to help you, but I don't need them right now. So we can rotate this door pretty easily, but it's the communication part. How do we send a message over? We could cast to the door. That would be like how we casted to the character to check. And then we could pull out of the the output there. So we could do this where we say, oh, I get the target door like that. We could cast to it. And that way we can interact. We could pull functions out of the door like that and find them and call them up. However, casting is actually it's not the most expensive form of communication. It's just a little expensive compared to a blueprint interface. So we're gonna make a blueprint interface, which is gonna allow us to create a direct pipeline of one function call. When you cast to something, you load the entire object. When you use a blueprint interface, you're only loading the exact data that you're trying to pull out of it. So in this case, for example, let's say you have a big dragon. It's a cool dragon, lots of stuff. It has a lot of stats. It's got like cool meshes and it's got like all these different things that it can do, tons of functionality. And all you really want to do is take its health and bring it down like 10 points because you hit it. You don't want to load up the entirety of this thing. You just want to pull up that bit of information and make a small alteration. So instead of casting, that's when you would use a blueprint interface. Casting, I like to think of it as, imagine you had a cookie jar with no lid. You want the cookies out of it, but how do you get them out? Well, you can smash it on the ground and pick up all the cookies. That's casting. It's bringing up everything at once. Versus you kind of come over and you tap it a little bit on the side and maybe you create a little crack and you pull one cookie out. There you go. That's interface. Way less mess and you're only getting exactly what you want. You're not smashing stuff all over the floor. So, I do recommend using interfaces as much as possible. So we have our little door idea. It's got a mesh, but it doesn't have any functionality. What we're going to do is hop back over here into our content browser, and we're going to right click, and instead of making a new blueprint class, you'll see there's a subsection for blueprints. It does have class here. It has the ability to make function libraries where you can extend the core functionality of a class and all of its children. Same thing with macro library. So if you're doing something where you're hopping in and out of user interfaces a lot, you could create a function which fires off all the change the UI mode, change the input modes from UI to game, back and forth. And it's way easier to just make it once and inject it. And you also have things like enumerations and structures where you can make your own custom variable types. In this case, I'm actually going to use the blueprint function, the blueprint interface right here, make a new interface. So the way that these things work is an interface is like a stack of functions. It's just like a little function library that we assign to a blueprint, any blueprints we want. And that little stack of functions that we're pushing into it are undefined. We define them per object. But this makes a really good sense of generic function calls. So instead of saying, instead of having the function library where everything's predetermined, now we can say, in this case, I'm going to call this interact interface. We can say anything with interact interface will definitely have our function. If I double click it, it'll definitely have our function. And we're going to name this one, use object. So anything that has this must be usable. And therefore, we can do something like, oh, line trace forward. And if we hit an object and it implements this interface, it must be usable. So it will definitely have this function. And then in the object, we change the function's meaning. So in this case, when we interact with the door and we actually call this function, we're going to define it in the door itself as rotate the static mesh of the door. We could put the same function into like an apple. And then if we called it in the apple, we could have it find the user and then say, hey, increase your health because you ate food. We can also use this just for transferring just any generic kind of data, whatever we want. But in this case, I don't need to change values, which would be changing the inputs and outputs. I don't need to change values. I'm just trying to make a function call, and then the function call will trigger the rotation. So we don't need to input or output any particular numbers or Booleans. It's just once this is called, rotate out or rotate in. All right. So as long as you call that use object, that's all we did here. It's like, wow, Alex talked a lot. And all I did was name that use object and I hit compile, please. If you do not hit compile, it will not actually show up or work or anything, and it'll be terrible forever, and you'll be like, why is it on fire? Hit compile. Every time you make changes, compile. In fact, let's save it too. Hit the save button and exit. As long as you name this use object, make sure you didn't leave that as new function 0. I don't want to come back later and someone's like, I left this new function 0, it didn't work. No, use object. We're good. Exit. Inside of our door, we're going to give it this interface. So we're going to hit on to our class settings. So open up your door, hit class settings, and here's where we drop in our interfaces. It's right here. Interfaces none, and you inherit them from your parent as well. So you make a core class like food, and then you implement like this pick up eat object kind of interface action, and then you derive children out of food, and they'll all be able to work exactly the same. So it's like make one solution and then make children for it, and it makes your life a lot easier. And in this case, we're going to hit add, and oh my gosh, there's so many interfaces. But if I type in interact, there is interact interface. Ignore the viewport, but we want this top one, interact interface. And once I hit compile, remember, we have to compile the interact interface and compile this. When I go to my event graph now, I should be able to right click and type in event use object. Cool. So basically, our lock knows this, will know that this function exists. And when it happens, we could do something. All right, let's see. Inside of our lock, now that this exists, we've made the function call. We're going to go back to our lock over here. And where it says our threshold is met, it says true, right? So instead of it being true, we're going to, not just being true, what it's going to do next is we're going to take that target door, I'm going to drag it over here, let go and get target door. And I'm going to show you the is valid check, basically. This is like an is valid check, but it's called does implement interface. So you can make sure that that target is using the interface. That's an is valid check. And then you choose which one you're searching for. So I just got the target door, drag from it, and type in does implement interface. Down here, ooh, it's because I have like a weird aspect ratio. There we go. And type in interact interface. Because I have it all zoomed funny, so it's popping in funny. There we go. Interact interface. And again, that's a Boolean value coming out. So we're going to branch. If it's true that we met the threshold and it's true that the target door does implement interface, branch, then we can call up the target door again, drag it out and get it. And now we can message out to that function call of use object. So drag off of target door. This is context sensitive. You won't be able to find this properly. You know, oh, you can, it just won't be hooked up proper. It'll look really weird. So drag off of here and type in our, there we go. We want that use object message. And so that's sending the signal out as opposed to bringing it in. Use object message. Hook it up to true. And that's it. Now we've got it rolling. Now we can test it. We can very easily test it by going to the door and then adding a print string on that function call. And then we'll put a door in the level and target it, and then that'll work. I'm gonna just tell you one little secret really fast. See this node here and this node here? They're the same node, right? Well, I mean, couldn't I just click this here? Yeah. Is it more or is it less cost? What do you think? More cost? Whoever thinks it's gonna cost me more if I have one guy getting stretched across? This is going to cost more. Show of hands. Anyone? No? Yeah, guesses? No? Okay, no guesses? It's fine. Basically, it's the same. It's a trick question. It's actually completely equal. As long as you're doing that getter and that one too, it doesn't matter. It's totally equal. You can have two of them. You can have one and then drag out 100 lines from it. So if you know somebody, and I'm sure that you do, who's used blueprints and loves to drag out 100 lines from one single getter, make them stop. They don't need to. It's the same cost because every time you call it, it's the same cost, even if it's dragging from the same node. So just a heads up. That one comes up a lot. Okay, so we're gonna go over to our door and we're gonna make sure that this communication's happening. So event use object, we're gonna define that as print string. So drag off of this in your door, type in print string, And we're going to say this one, door will open now, but we didn't put in that function yet. Don't put in all this. Just put in hi or something, and we'll get the idea. There we go. Door will open now. We didn't put that function in yet. Hey, we get it. So we got a lock. We got a door. Lock and door. Let's put our door right next to our lock. There's our door. I'm just going to drag it out. Hey, door, what's up? Boop. Now, grab your lock. And where it says target door, remember, because we made that instance editable, it's exposed, we can set that variable manually in the level. So we're going to choose, there's our door. Now that we put one in, we could put in other doors. We could have multiple doors and then choose one of the doors. It's a single target right now. We could make it an array and then choose a ton of doors and all the doors open at once with an array. Instead, we're just going to do one at a time. So I'm going to get rid of that second door. That was just to prove a point. And door. That's it. If you don't select that target, what will happen is this does implement interface will fail because you don't have a target. So this acts as our is valid check. So we won't end up with a race condition where you're trying to do something and then, oops, we forgot to actually have a target or we lost track of the target. You want to put in some checks for that. All right, that's all we have to do. Let's check it out. I'm going to go in. We're going to hit play. I'm going to try to get this viewport open. I heard somebody shoot. That means we're all playing. That's good. So I walk over. I hit E. Oh, there it is. Ah! Remember, that print string is in the door. Oh, shoot. Sorry, my mouse keeps sliding down this. There we go. So the print string is in the door. And so we can actually do that trick again. And I love doing this trick. You know I do. Where we can look at the door. And we can look at ourselves playing in the game. There it is, that use object. Now it's not going to ever go through here until the last one is hit, and it goes through that upper branch. So 1, 2, 3, 4, 5, 6. There it is. Now it's coming through. Yep, we could follow that same logic. Oh shoot, I didn't mean to close the door. Sorry, don't close the door. So we can follow the same logic over here. We can see it firing off by hitting play. I can bring this down a little bit. I can bring it up. There we go. So inside of the lock, this is what it looks like. I come over, I hit E. The first branch that we're looking at there is the threshold, and the second one is does implement. So 1, 2, 3, 4, 5, 6, and it shoots right across. And then this use object acts as a tunnel. It is a tunnel that shoots the message through one object to another. It's coming out here, which means that now we control the flow. Like I was saying, the water is flowing. Now it's going to flow out here. So let's trigger some rotation. We're going to get that door and we're going to rotate it. So hop into your door with me here. Control-Shift-S is your friend. Control-Shift-S is save all. Control-S is save the current object you're on. Big difference. Control-Shift-S is your friend. Control-S will trick you into thinking you did the right thing and then destroy your game. Control-Shift-S. So, use object. We know that that door mesh here is what we want to rotate. So I'm going to drag my door mesh into the scene here. There it is. So now we have a reference to the mesh. And all we have to do is say, I'm going to drag off of this. We can say set relative rotation. There it is, relative rotation. And we're going to make it pop open first. Then we're going to make it open up smoothly. Let's just see it pop open. And we can do this by rotating 90 degrees on the z-axis. 90 Z. Now, the way that you know which way things are going to rotate is you take your left hand like this, and then you put it out and you make a gun like an American gun, and you put out one finger like this because you don't know what you're doing. So this, and this are your three axes. Your Z axis is up. So Unreal is a Z up, Y forward, X forward, Y right. Whew, I see Chris about to laugh at me because I said that. Sorry. And we've got our Y right. So X is forward. So if I rotate on X, I will roll my head like this. There you go. And if I rotate like that, then I'm going up and down. That's on the Y axis. So you can grab each finger and just remember Y, X, Z. So that's like a door right there. That's the Z axis. Now, if you actually look at a chart of all of the different ways that Maya, Max, and all these other 3D softwares are using this kind of an axis, some are right-handed, some are left-handed, some are Z forward or Y forward, and they're all different. And Unreal is very unique in that it is the only one that is all of these combinations. It is left hand, Y, this way, X this way, Z up. And the reasoning for that is, if you go on Twitter, you can actually find the quote from our CEO, Tim Sweeney. They asked him like a quick little question, like, why is this the axial directions, right? And he said, I was young. I'm sorry. Basically, he was about 19, 20 when he was writing it. And yeah, it just, he didn't know what everyone else was doing. He didn't think about it and just goes, yeah, Z's up, X is forward, Y is right. Let's move. And oops, we're actually totally unique for that. So in case you're wondering why, we inherited from Unreal 1, Unreal 2, Unreal 3, and Unreal 1 was made by a 19-year-old kid who was learning how to make engines. So if you have a 19-year-old kid on your team who's learning how to make engines, he could be the next Tim Sweeney, worth 4.5 billion now. So in this case, we've got that Z forward, and I didn't say it, but this is ready. We can go try again. Let's just hop in, and I come up, there's my door. 1, 2, 3, 4, 5, 6, and it's open. Hey! All right, I'm kind of fat. That's the problem. So my capsule, which is what's happening here, my capsule is a little bit big, but it opened. That's good. We can actually kind of cheat by just selecting it. And if we want to like scale it up, let's make it a mega big door. Just make it 2 by 2 by 2. Mega door. Very important. All right, so now we'll be able to fit through it. This is so cheap and lazy, but don't worry, we're just doing tests. There we go, and hey, we can go through it, and the door's actually got no collision, but you get the idea. Now it's open. Great. Wow, fancy. All right. Now let's actually fix up that rotation so it doesn't look so terrible. Like, this isn't a game from the early 90s where the doors just slam wide open, We should make it rotate over time. So instead of setting our relative rotation like this, I'm gonna just scooch it on over. And I'm going to scooch that door mesh on over. So we're going to disconnect it holding Alt, left click to disconnect the execution pin. And I'm going to introduce you to one of my favorite blueprint features. And there's people like, why do you use blueprints and you don't really care for C++? It's like, well, there's a few things that I don't like the syntax and this. But I'll tell you this, timelines are a really good selling point for blueprints. So if I drag off of this execution and I type in timeline, this is going to let us create a curve without having to sit there and doing curve math, because I hate curve math. Curve math sucks. Instead, we're just going to draw the curve. Wow, what a novel concept. Draw the curve, be done with it, and move on with your life, right? So add timeline. So I'm going to call this one door open slash close, because we can use the same curve and run it backwards, right? Yeah, it's awesome. So we have door open close. So update here, we're going to connect that to our relative rotation. So what this does inside of here is going to be a little chart. If you double click this node, it's going to open up a new sub editor for you. Double click. There it is. So we have a new tab, door open close. And you can actually see up here, we can make a new float track. So it'll output a float curve. So just a curve with a simple flat float. Or we can do it with a vector. So it'll give us 3 floats all intertwined with each other that become a vector. We also have an event track. So over time, you can fire off events and then create like a series of function calls over time. So this is cool. I actually know a guy who's making like a Rock Band style knockoff game. And that's all he does is like event track. And then he just finds the timing of each thing and manually does it, which I think is crazy, but it works. You also have a color track, which is basically a vector plus a 4th channel for alpha. So it's just a vector it's a 4 vector, basically. I wish they would just call it 4 vector, but that's just me. You can also make your own curve assets, which are a unique asset. You can make an asset type inside of your content browser and then basically add it here. But in this case, we're gonna hit float. There he is, F. And we can see up, I'm sorry, I have to name it first. Let's name this door rotation. Door rotation. All right, now if I zoom out a little, there you go. You can see there's a light gray area and a dark gray area. Just gotta zoom out. From the left to the right, up top, you can see 0, 1, 2, 3, 4, 5. 5, this is seconds over time. The length here of 5 is what determines how long this curve is gonna last. So I don't take 5 seconds to open a door. That feels kind of weird. Let's make it 1. 1 second. There we go. Wow, it's so short. Whoa. If I zoom in, you can also see there's a 1 and a 0 over here, and that's the value it's going to output based on the curve's position over time. Now, the way to keyframe, you put in some keys, is I hold shift and left click, and I'm gonna start at 0 here. So I'm gonna click around time 0, value 0. And you can see I didn't quite make the time right, but I can select that little pinpoint and then manually type in 0 and 0. And that'll be our start. Our starting rotation will be where it is by default. And then I'll go over to 1 second at the end and a value of 1. I'll hold shift, left click. And so now it'll go straight up. So it's a very linear curve, a little ugly. But if I make this a time of 1 and a value of 1, now we can like lerp blend between two values of open and close. It's way easier. So I do recommend you if you don't want to have crazy large curves, just go between like 0 and 1 and then multiply it out to make whatever number you want. It actually gives you a lot more control that way. I can also right click on this key right here. I can put in auto user break, and this is our interpolation. This is our way that the curves should meet each other. If I click auto and auto, over here, you have to do them both. There we go. Now I have a nice smooth curve. So you won't really notice the difference on the door kind of opening like this perfectly versus like a little bit of slide in and slide out kind of thing. But when you want something to move on a curve and you want it to be nice and smooth, you can do it like this. We could even make it so that the door kind of pops a little bit. So give it a little stylized curve. So it actually goes a little bit above, maybe get a little bit below. So it kind of does that kind of cool game thing. You ever see like a door kind of like chunk? So it does a little push forward before it opens. So that's what I've done by altering the curve ever so slightly to go down. So that'll just give it a little stylization. Nothing fancy, just a little stylization. Okay, now if we go back to our event graph, you'll see there's our door rotation output, and that's gonna go from 0 to 1, just like I said, as time goes forward. All we have to do is tell it to play from start. I can hold control, see, because it made it on play by default. Hold control, left click and drag, and now I can reroute our wire. So I don't have to keep cutting them and pasting them. I can just move it over one. There you go. So we'll play from start, compile, and we just need to say right here, this target rotation, we're going to kind of lerp between two values. So I'm going to drag off of this. I'm going to type in lerp rotator. So if you're not familiar with the concept of linear interpolation, lerp, basically we have an A value and a B value. And as we go from 0 to 1 on the alpha, 0 would be A and 1 would be B. So I'm going to make B 90 and A will be 0, 0, 0. And then door rotation, boop, there you go. Now let's try it again. Let's see what happens once we go back out into our world. How am I doing on time? Well, that's perfect because this is the end. 1, 2, 3, 4, 5, 6. There it goes. Gorgeous. So it rotated out properly. That's it. If you wanted it to, you could actually now kind of flip-flop it where flip-flop. So play from start. We could actually do play and reverse. And this is a flip-flop, which is going to do A the first time and then B the second time. So I come out and this little flip-flop, 1, 2, 3, 4, 5, 6. It opens, E again, it closes, and now it opens and closes totally all the time. Very easy, done and done. And I can actually kind of interrupt its opening and closing because it's just moving up and down that timeline right now. Come on, mouse. There we go. All right. So that's kind of the gist of it. I just wanted to show you guys all these cool little features. I'm going to show you a couple. Oh, well, I don't have internet, so I'm going to just tell you. You should go to docs.unrealengine.com and just look up our quick start guides and how-to guides. Then instead of using a volume, we could have done a little bit of vector math, figured out what we're looking at, and use whatever we're looking at through a line trace, and then using a function call to that. I am working on putting up a nice intermediate tutorial that would kind of build off of these concepts. We're going to have it put onto learn.unrealengine.com. If you're not familiar with learn.unrealengine.com, well, my wife runs that, so that hurts my feelings. Come on now. Now, go to that. That is our kind of more like official academy style. You'll go through a series of video tutorials with some written text helpers, and it has subtitles. Everything has subtitles. This is her job, is she makes sure it all is nice and subtitled, because you're hearing British people and Americans and an Australian, and they just have this, they have the dumbest accents. I'm so sorry. No, I'm sorry. I should apologize. I'm from the South. The way that I sometimes say, howdy, y'all, you guys all right? And it's good. All right, cool. You didn't understand anything I said. It's okay. That's the deep South. So we don't actually talk like that normally. So luckily we have these guys, we have transcripts, so you can read through what people are saying. You can actually, they're not done verbatim, so it's not the exact words. Instead, it's what they're trying to tell you. So we tend to stumble over ourselves when we're giving tutorials. So please go to learn.unrealengine.com. You're going to end up finding a bunch of video tutorials on how to use Unreal, basics, advanced stuff. They'll give you tests to make sure you understood things. If you fail the test, they'll tell you, they won't just be like, man, you failed. They'll tell you exactly what concepts you misunderstood, and they'll tell you how to better understand them. You can take it again, and we'll give you badges. So you can actually give yourself a nice little badge thing. So if you're a teacher and you have students, guess what? Now you can actually check to see their progress. If you're just somebody who likes earning achievements on Steam, well, yeah, it's basically Steam achievements in a way. So, use those. All right.